Okay, so in section 6.1, um, we were undoing the power rule with an antiderivative. So in 6.2, we're actually going to undo the chain rule. So some general antiderivative formulas. If you have the antiderivative of some function to the nth power times the derivative of that inside, this is just f of x. This is the reverse of the chain rule. So 1 over n plus 1, you're going to increase and divide the whole function here. The fact that that derivative is sitting there is helpful and what allows this to work. Then I will go through this. Let me try to get this set up so that these don't run into each other. Oh, okay. Remember, if you are taking the derivative of e to the u, the derivative of this d by du is equal to e to the u du, or if this was e to some function times that the derivative of that function. So undoing that, this is equal to just e to the function. One over the inside times the derivative of the inside. This is a thing we did. This is the derivative of the natural log. So this, the antiderivative, this would be the ln of absolute value f of x plus c. Oh, I forgot my plus c up here. Okay, and if we look inside at this again, just an increase and divide thing. So u to the n plus 1 over n plus 1 plus c. The integral of e to the u du is e to the u plus c. And 1 over u du is the ln of absolute u plus c. Okay. The hardest part is determining here, but we're going to be making substitutions. So, I mean, you can see how this goes with this, and this goes with this, and this goes with this, right? This is 1 over u du. This is 1 over the inside times the derivative of the inside. The integral of e to the u is e to the u. The integral of e to a function times the derivative of that function is just e to the function. So these are like, this way is generalizing these rules that we did last time. Here, the hardest part is figuring out what is the substitute, which is the outside function, right? Outside versus inside functions. And so practice is what makes that make sense. Hopefully you can look at this and see I was going to write that out in more detail, but that looks really horrible. Actually, maybe this will make this make more sense. The derivative d by dx of f of g of x, there's an outside and an inside function here, right? Is the derivative of the outside, leave the inside alone, times the derivative of what's inside. So it makes sense that you would take the integral of f prime of g of x times g prime of x dx and get f of g of x. Or in this case, we're going to look at the integral of f prime of u du, and this would be f of a, something, u, f of u. Okay, so what we are looking at here, we want to try to identify, so we're looking at like stuff that looks just like this, and we're trying to identify these pieces, the outside function and then the derivative of the inside function. So here, I hope you can see that like something cubed is the like big function, and the g here is x squared plus 1. So this is like u is x squared plus 1, and f of u is u cubed. So you're going to let this be that u is x squared plus 1. Notice how, looking at this, we need f prime of u du. A du, we don't have a du, we have a dx. So what we're going to do is find du. So take this derivative, this would be 2x dx, and this is what you're going to do every time. Basically work this out. So u is x squared plus 1, du is 2x dx, and you're going to make the substitution. You're looking for this in your integral, and you're going to substitute it. So here we have that this is actually equal to the integral of u cubed, that's x squared plus 1 cubed, times du. And then, because everything is in terms of u, we can take the integral with respect to u. So we're looking at u to the 4th over 4 plus c. And then plug that u back in. So x squared plus 1 to the 4th divided by 4 plus c. This is not that easy, but hopefully a lot of practice will make this make sense. I'm going to move this over. Okay. Number 2, I'm actually going to make a bunch of these so I can separate this stuff. Whoa. Oh my goodness. Oh, why don't I just draw lines? Why don't I just draw more lines? Okay. So, oh my gosh. All right, let's do a couple of these. Okay, so we have the integral of x cubed minus 1 to the 5th, and then 3x times 3x squared dx. So this is our big function, the inside function, which we want to make sure the derivative is there. So the inside function is u, that is x cubed minus 1. Its derivative is sitting there. That's 3x squared dx. We're going to replace this with du. So this is equal to the integral of u to the 5th du. So just like literally replace that. And then you have everything in terms of u, so you can just integrate. So this is u to the 6th over 6 plus c, which is going to be x cubed minus 1 to the 6th over 6 plus c. All right. Again, the inside function here is x cubed, and its derivative is sitting there. That's good news. So u, the inside function, is x cubed. Du is 3x squared dx. So again, we're going to make that substitution for du. So this is equal to the integral of e to the u du, which is e to the u plus c, which is going to be e to the 3x squared, to e to the x cubed, sorry, plus c. Now you could go back through with any 3 of these, take the derivative of this, and you should end up here. Take the derivative of this, and you should end up here. Take the derivative of this, and you should end up here. If you don't, something's gone wrong. Okay, keeping going. This is the inside function. I can tell 1 over this thing, that's the outside function, and the derivative of this is sitting there, so I'm in good shape. The inside function, which is u, is 1 plus x squared. Du would be 2x dx. So replace that with du and go. So this is the integral of 1 over u du, which is the ln of absolute u, plus c, which is equal to the ln of absolute 1 plus x squared plus c. Okay. Continuing on, practice is going to make better. We have lots of it to do. Whoa, 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 whoa. Yeah, okay. That's a lot of practice. Okay. Number 5, the inside function u is x squared plus 1. Du is 2x dx. I have this is equal to the integral of x squared plus 1 to the negative 2x dx. So notice I have an x dx. I have that here, but I need to get it by itself. So I'm going to divide both sides by 2. So I have 1/2 du equals x dx. And then I can substitute that part in. So this is equal to the integral of u to the negative 2 times 1/2 du. Dx dx is 1/2 du. And then that 1/2 I can actually pull to the outside. So this is 1/2 the integral of u to the negative 2 du. So we're going to increase and divide and add c. So I have that this is negative 1 over 2u plus c. So that is negative 1 over 2 times x squared plus 1 plus c. Okay. Let me shrink some of that to make room for this. So again, you're looking to replace the function, the x's and the dx with something in du, some constant in du. So hopefully we'll get to do that again here. Yeah, this will be off by a constant as well. So looking at number 6, the inside function is x cubed. So u is x cubed. Du is going to be 3x squared dx. Notice that what I have here is actually 6x squared dx. So I'm going to write this as 2 times e to the x cubed times 3x squared dx, because that is what I actually can substitute in for. And 2 times 3 is 6. So I've taken that and just split it up into the parts that I want. Hopefully that makes sense. This is kind of tricky. Okay, so this is actually equal to 2 times the integral of e to the u times du. And then that would be just 2e to the u plus c, which is 2e to the x cubed plus c. Another way to have done this instead of splitting that up, maybe I should do this in purple. Let's see, I'll move this over here and over here. So another option would be to recognize that I have sitting here 6x squared dx, so make that happen here. So this is 6x squared dx. That means that this would be 2 du. And then you can actually make that substitution. So you would have e to the x cubed times 6x squared dx. And that would be equal to the integral of e to the u times 2 du. And then just pull that 2 out and do the integral of e to the u du, which would be 2e to the u plus c. And then that's 2e to the x cubed plus c. So that's a thing you can do too. Work with what you have and like rearrange it, or work outside of the equation to get what you actually have outside of the integral. So number 7, we have the integral of x cubed over 1 minus x to the 4th. So this is my inside function u. U is going to be 1 minus x to the 4th. Du would be negative, exponent down front, decrease it by 1. So negative 4x cubed dx. I don't have that in my integral right now. I just have x cubed dx. So I'm going to divide both sides by negative 4 to get that by itself. So I have negative 1/4 du is x cubed dx. And then I'm ready to make my substitution. So this is actually the integral of 1 over 1 minus x to the 4th times x cubed dx, which when I make my substitutions, that's 1 over u times negative 1/4 du. That negative 1/4 I can take out. So I'm looking at the integral of 1 over u du. And then the integral of 1 over u is the ln of absolute u plus c. And then that's going to be negative 1/4 times the ln of absolute 1 minus x to the 4th plus c. Okay. Number 8, the inside function u is what's on the bottom there. So 3x squared minus 1 du is 6x dx. Again, rewriting this, you can see I have 1 over 3x squared minus 1 squared times x dx. So this is what I have. So I'm going to divide this by 6. So I have 1/6 du equals x dx. So I'm ready to make my substitutions now. So this is the integral of 1 over u squared times 1/6 du. That 1/6 can go out here. So 1/6 times the integral of 1 over u squared, increase, so u to the negative 1 and divide by negative 1 and add c. So we're looking at negative 1 over 6 times u plus c, which is negative 1 over 6 times 3x squared minus 1 plus c. Okay. Looking at this one, the inside function, I hope that this is making sense. It's hard to teach this without looking at your faces. The inside function u here is negative 2y cubed. So du would be exponent down front, so negative 6y squared. Exponent down front, decrease it by 1, and then dy. So what we have in our integral, if you go back and rewrite this, this is equal to the integral of e to the negative 2y cubed times y squared dy. So I need to get that by itself, that y squared dy. So I'm going to divide by negative 6. So I have negative 1/6 du equals y squared dy. And then I'm going to make that substitution now. So we have that this is equal to the integral of e to the u times negative 1/6 du. So negative 1/6 times the integral of e to the u du, which is negative 1/6 e to the u plus c. And then e to the u is negative 2y cubed. All right. Number 10. This is fun. Number 10, we've got a quadratic on the bottom and a linear function on the top. That's good because that linear function on the top is the derivative up to a constant of the bottom. So the inside function u is that bottom thing, x squared plus 5x plus 2. Du is going to be 2x plus 5 dx. What we actually have is 2 times that, so 2 du is 4x plus 10 dx, and then we're ready to make our substitution. So this is equal to 1, we can write this like this, 1 over x squared plus 5x plus 2 times 4x plus 10 dx. And then this is actually equal to the integral of 1 over u times 2 du. So that is 2 times the integral of 1 over u du, which is 2 times the ln of absolute u plus c, which is 2 times the ln of absolute, that quadratic x squared plus 5x plus 2 plus c. All right, number 11. So here, maybe the inside-outside function is not very obvious. I think it is the least obvious on this one. But if we let, so we need du. Present up to a constant, right? So we can make that substitution. So the derivative of the ln of x is 1 over x. So that's the inside function. U is the ln of x. So du is 1 over x dx. And we have that sitting here. If we rewrite this, we have the integral of the ln of x times 1 over x dx. And so we can make the substitution. This is the integral of u times du, which is going to be u squared over 2, because this is u to the first, plus c. And then u is the ln of x. So this is the ln of x squared divided by 2 plus c. I think that's probably the hardest one in identifying the inside and outside. But again, you need the du to be present. So we want 1 over x dx to be our, to be the like derivative of the inside function, whichever we choose. Okay. Similarly here, you need the du. This is the u because this is du. So u is x squared plus x. Du is 2x plus 1 dx. So we can actually just substitute that. So we're looking here at the integral of e to the u times du. So this is e to the u plus c. So this is e to the x squared plus x plus c. The nice one after number 11. Okay, number 13. Again, you want the derivative of the function you choose to be u to be there. Since this is squared and this is x, we would be in good shape to make this thing our inside function. So u is 3x squared minus 1. Du is going to be 6x dx. Now, if I rewrite this, what do I actually have? I have 1 over 3x squared minus 1 squared times x dx, right? I have an x dx. So I'm going to divide this by 6. So 1/6 du is equal to x dx. Sorry, let me change all this to blue. Okay, and so I can make this substitution now. This is the integral of 1 over u squared times 1/6 du. So I have 1/6 the integral of 1 over u squared du. I'm going to increase and divide. Did I already work this problem? No. I'm going to increase to -1 and divide by -1 and then add c. So this is negative 1 over 6u plus c. So that's negative 1 over 6 times 3x squared minus 1 plus c. Are we sure I haven't done this already? That seems very familiar. Oh, the 1/6 was e to the u, but oh, no, here. Is that the same problem? It is. That's interesting. That means that's the same too? No, it's not. Okay. Well, anyway, there's that problem twice. Maybe it'll show up again. Number 14, the inside function here is this. Let's see if that works. If we let u be that, do we have the du present? So 1 minus 3e to the 2x. Du would be negative 3e to the 2x times 2 dx. So this would be negative 6e to the 2x dx, which we are pretty close to having. We have e to the 2x dx. So if I rewrite this as the integral of 1 minus 3e to the 2x squared times e to the 2x dx, that's the thing I need to substitute here. So I'm going to divide by negative 6. So I have negative 1/6 again, du equals e to the 2x dx. So making that substitution and my u substitution stuff, I have u squared times negative 1/6 du. Oh, good. That's not u to the negative 2. Phew. And then I'm going to increase and divide. That 1/6 comes out. So the integral of u squared du. So I'm going to increase and divide and add c. So negative u cubed 1 minus 3e to the 2x cubed over 18 plus c. All righty. Number 15. Number 15, the inside function is u. That's it right there. U is 5 plus 2x squared. So is the du there? Du is going to be 4x dx. So I'm going to replace x dx with 1/4 du. So I'm just going to pull that 6 out for right now and write this as the square root of 5 plus 2x squared times x dx, and then make all my u substitution stuff happen. So 6 times the integral of the square root of u times 1/4 du. So this is 6/4 or 3/2 times the integral of the square root of u du. So increase and divide. So increase to 3/2 and divide by 3/2 or multiply by 2/3 plus c. So these cancel. So I have 5 plus 2x squared to the 3/2 plus c. Okay. Let's see. U here is 3y squared plus 7. That's the inside function there. It's under that cubed root. So du is going to be 6y dy. I have 4y dy, but I'm just going to pretend like it's just y dy. So I'm going to pull that 4 out. So I have the cubed root of 3y squared plus 7 times 4. No, times just y dy. So divide by 6, divide by 6. So 1/6 du is y dy. And then I can make my substitutions. So I have 4 times the integral of the cubed root of u times 1/6 du. So I'm looking at 4/6 or 2/3, the integral of the cubed root of u du. So that's a 1/3 power. So I'm going to increase to 4/3 and divide by 4/3 or multiply by 3/4. So I have 1/2 u to the 4/3 plus c. So 1/2 3y squared plus 7 to the 4/3 plus c. Oh, and that's it. Okay, so again, this is like, it's the same thing over and over again. Figure out what the u is, figure out what du is, see what you need, what constant you need to get there to replace it. I always do this work outside of the equation, and then make the substitution into the equation. This is typical for me. It is maybe not what your textbook does, so just be aware of that. I find that I'm less likely to mess up, like if it's 4 or 1/4 or whatever, I'm less likely to mess up if I work it outside of the equation, looking at what I need to have and then figuring out what I need to do to get it. Okay, so that is 6.2. You guys email me if you have any questions. I would be happy to help you. Thank you very much.